Oh my gosh.
Hi, everybody. How's it going?
Good, how are you?
Great. I'm expecting more people, but I always like to start right on time. And usually I have a subject predetermined, but I kind of scheduled this session last minute and didn't have a particular subject in mind. So I thought we could take a vote if y'all want math, science, social studies, language arts, or fine arts.
Mhm. I'm open for anything.
Anything? Okay.
Mhm.
How about Javon and Jessica?
Anything
I'm
but language.
English
Like
language arts? Does that sound good, Javon?
no,
I'm
anything but
open
that.
for I'm open
Anything
for
but that.
anything. Maybe math.
Yeah,
Math
let's
is
do
my weakness.
math.
Math?
Yeah,
I
Okay.
agree.
math.
Well, math is always a popular one. So let's do some math. So I have courses for all subjects, but let's do math. Um, so as you probably know, there's lots of study material out there for the EC through 6. And I've bought lots of different programs before I had my own study material, and a lot of it's really good. But what I thought about some of it was it's overwhelming, right? So when I created my courses, I tried to create courses that are really concise and to the point that are going to save you time, that don't have a bunch of unnecessary information on the test. On the math, I didn't find a lot of unnecessary stuff on the different programs that I bought, but on social studies I did. I found a lot of like world history that's not really on the test.
Oh,
Yeah, it's real heavy on Texas history and US history, but they barely mention world history. So if you study, and I have world history in my course, right? I do have it, but I tell you ahead of time, this is probably not going to be on your test. That way you're not spending a lot of time, kind of like on fine arts, when it asks you the history of culture and music and stuff like that. That's probably not going to be on your test. So I know because I've taken the test and if people ask me questions and I never share what's on the test because we sign that affidavit, right? But I know the topics and the concepts and that's fine to share, but I don't share specific questions. Um, so I think last time when I did free tutoring, we did instruction and assessment, which is like how to teach math. So I'm pretty sure you can find that on my YouTube page. So let's do patterns in algebra because I consistently hear from people I need help with algebra, right? We kind of forget what we learned in eighth or ninth grade. Um, so we'll do some, and it is pretty basic algebra. We're not talking algebra 2, pre-cal, anything like that. But still, basic algebra can be tricky for some people. So we'll do some basic algebra, but some of this is not algebra, it's also patterns. So you'll see that we'll do both. And before we get started on the actual tutoring, I also like to show you guys some data because I think it's always good to back up what I say with data and show you guys. So if you Google EPP passing rates 2023, it'll come up the most recent pass rates from 2019 to 2024. This is a document by the TEA and it shows you how many people, and it tells you right here, first attempt. So this is the first time test takers, how many people pass their test, which is good to know, right? So let's look at core subjects, EC through 6. You'll see the 800s and the 900s. We want to look at the 900s. The 800s was the old EC through 6 test that they phased out a long time ago. So let's look at math, which is what we're talking about tonight. You can see 77% of the people that take it for the first time pass it. So that's pretty good. It's not as high as fine arts and ELAR, right? But it is, let's see, it is higher than social studies. Social studies is only 74 and science is 83, right? So you can see it's in the 70s to 80s, right? So a lot of people pass the test on their first try, but there's a good 20 something percent of the people that don't, all right? And some of them don't pass on their second attempt either if they don't have the right study material or maybe they don't have good reading comprehension. You have to have good reading comprehension to be able to pass this test. So if you know you struggle with reading comprehension, I would recommend that be your first thing is to Google and YouTube reading comprehension strategies, right? You want to do metacognitive strategies. The other thing I want to show you that's free is Google Texas NESIMC manual. This is the free manual, which is on the same website where you go to register for your test and where you'll get your scores when the scores come back. But click on prepare and then scroll down and click on core subjects EC through 6. And if you want to see what the questions on the real test look like, these are super similar to real test questions. You don't get any closer than that, right? And then they just launched this down here within the last couple of weeks. I've never bought it, but I'm sure it's good because it's from the same people that write the test. So I think this is good. But if you already have my course in tutoring, you don't need to buy this. My course in tutoring, not tutoring, sorry, my course has everything that you need to pass. So you don't need to buy this because that'll add up. You have to buy each one separately. Right? So it's not going to be cheap if you have to buy all of them. But well, they do have a bundle, so that's good to know. So you could actually get a bundle that's not that bad. But you don't need this if you already have my stuff. I don't know how comprehensive it is, if it's really got everything you need to know, but I'm sure it's pretty good since the state puts it out. The other thing you can do that's free to study, but you want to do this after you've already bought a good study guide or course and done that, is just Google release star tests. And you could take release star tests for math, science, and social studies, and then see what you missed questions on, and then you'll know what you need to work on. But let's get started on some algebra and some patterns, right? So some of this is just about teaching math, not about actual math, right? So we need to know research-based theories and principles of learning mathematics, right? So studies show that appropriate classroom management, collaborative learning, motivation, and effective teaching strategies improve the results of math scores for students. This comes at no surprise since these are traits of a learner-centered classroom. So classroom management, that's something I didn't study before my first year of teaching, and it made my first year of teaching very difficult. So you definitely want to do that. But they might ask you questions about research-based series, and one of them is having good classroom management, because if you don't have control of the classroom, doesn't matter how much math you know, you're not going to be able to teach it to the students because it'll be too chaotic. We want to use collaborative learning. These ideas stem from Lev Vygotsky's interactionist theory about students working together, and it builds their cognitive and linguistic skills. So them working together in small groups. Motivation. We know if students are more motivated, then they're going to learn faster and better, right? Some students will be naturally motivated, and those are usually easy to teach. And some students might require some extrinsic motivation on our part that we have to think of a reward for them, right? So we've got to meet the needs of all students. Effective teaching strategies. Everything should be learner-centered, focused on the needs of the students. You should use differentiated instruction. That means you plan activities to meet the learning styles of visual, kinesthetic, auditory learners, people with different cultural backgrounds, different interests. We already mentioned the learning styles. We mentioned collaborative learning. A lot of people miss questions when they ask about the best way to teach a concept, those situational questions. If they're asking the best way to teach a concept, depends on the wording of the question. But a lot of times the correct answer is going to be small group targeted instruction, right? So, and people tend to think we should always use heterogeneous grouping, where we group students of different backgrounds, different interests, different readiness levels, different ability levels. But research shows when we're doing small group instruction, we want to group them by skill level, right? And it's not static. It doesn't mean that your advanced kids will always stay advanced and your struggling students will always stay struggling. You're constantly assessing and regrouping. But the reason we do this is because if you have some kids that have already mastered 2-digit addition and they're on 3-digit addition, then we need to help them on that. And some kids are still working on 1 and 2-digit addition. We need to help them on that. But if we mix them all together, we can't do that, right? So we group them by ability level. for small group targeted instruction. But when we're doing collaborative learning, we do mix them up heterogeneously. We want to use non-linguistic representations like charts, pictures, graphs, diagrams, songs, rhymes, chants, manipulatives. If you need to learn more about non-linguistic learning, the book Classroom Instruction That Works has a lot of information about non-linguistic learning. It also has a lot of good information about classroom management. Right? Teach them metacognitive strategies. Those are strategies to think about their own thinking, self-evaluation. Help them make goals and give them feedback. Feedback needs to be substantive and timely, so meaningful, right? So it can't just be good job. We need to have constructive, positive feedback that is specific and timely. So we don't want to wait 2 weeks to get back to them, because in those 2 weeks, they might be practicing the same mistakes that they were making when they first turned in the assignment. Homework should be meaningful, and so should classwork, not busy work. Okay, everything should be learner-centered, like we already talked about. That means the students are actively engaged. Oh, goodness gracious. No wonder this didn't seem like patterns in algebra. Sorry, guys, we were on competency one. I'm sorry. I was wondering when we were getting to patterns in algebra, but that's okay. Y'all got a little review of competency one. So functions. A function is a relation between a set of inputs, x values, and corresponding outputs, y values. You can think of a function as a machine with an input coming in and the output resulting. A variable, as we know, is a letter that's a symbol of something, like usually x, right? The function notation, the way we write function is f of x, and that's how you pronounce it, f of x. So for example, f of x equals x divided by 3. Each input x has only one output. If it has two outputs, it's not a function. It would not pass the vertical line test. So we can make concrete models of functions, right? So one way to do this that's a visual way for them to do something hands-on is to give them sheets of paper, tell them to fold one paper in half, 1 in 4ths, 1 in 8ths, 1 in 16ths. And then they're going to cut a hole in the middle of each paper along the folded side and see how many holes they get. So X is the number of pieces they folded it into. Y is the number of holes that they'll see when they unfold it, right? So that's a simple function. And then after they make the chart, they can make a graph. They could say, oh my gosh, all of these are half of that. So f of x equals 1/2 x, or y equals 1/2 x. See how all of these are half? 1 is half of 2, 2 is half of 4, 4 is half of 8. So this is a function, and then they can graph the function. Linear functions means the slope is always the same. You do have to know slope on this test. Slope is notated as m, and it's the change in y value divided by the change in x value. Sometimes we call that rise over run, right? So for example, y equals 2x is a linear function. We can graph it and make sure that it's a straight line, or we could notice that it's got a constant slope and know that it's a linear function. So if it has an exponent, it's not a linear function, right? So here's a simple table, and then you graph it and you get a linear function. Now, if you want a concrete model of a linear function, you could use counters to help them see, like blue counters and green counters, and they could see the XY chart and how they relate to each other. Now let's look at this function. This one's got an exponent, so I already know it's not a linear function, right? So look at the values. The x value is 1, 2, 3, 4, 5. Y value is 2, 6, 12. See how these are going up faster. And the line is curving up. So this is an exponential function. Algebraic reasoning. So some of us think algebra is like for 8th and 9th graders that are in high school. But even in kindergarten, we start to use some algebraic thinking. Like if I say, I have 3 cats, but I want 5, how many more do I need? And they count up. That's really the same as 3 plus x equals 5, right? And they know it's 2, but they just counted up on their finger. That's algebraic reasoning that we can do even in the lower grades. Then as they get older, they use more advanced algebraic reasoning. By fourth grade, they should use an input-output table to create a number pattern that follows a given rule, like doubling a recipe. That's a real-world way to make it relevant to them, right? So you can give them an original recipe, and then they have to double it, and you can make it visual, like this. It's really good if you bring in stuff to make a recipe and double it, right? So I know, like when my daughter was in first grade, they made applesauce. They didn't double a recipe because that's not a first grade skill, but they followed a simple recipe, which they called an algorithm, and they made applesauce. Implicit rules are implied, understood, but not specifically defined. Explicit rules are clearly defined. For example, students counting by fives likely understand the implicit rule of adding 5 to get the next number in the sequence, but are not likely to be thinking of a specific equation or function. An explicit rule of counting by 5 would be y equals 5x. So even in first grade, they can count by fives, right? But they wouldn't understand the equation y equals 5x. That's explicit, but the counting by fives is implicit. So we want to teach patterns. You know how to do that. Number families, like 5 plus 6 equals 11 and 6 plus 5 equals 11. Also 11 minus 6 equals 5 and 11 minus 5 equals 6. So they should look for patterns in data. Students can use number properties, commutative, associative, distributive properties. You do have to know those properties to figure out mathematical problems in real-world scenarios. For example, if a student needs to add two numbers, he or she would know the numbers can be added in either order and the result will be the same, right? That's the commutative property, that we can move the numbers around and get the same answer. Associative property means we can change the parentheses and get the same answer. And distribute is when you're multiplying over addition or subtraction. A function is a relation between a set of inputs and the corresponding outputs. Each input will have only one output, so each x value will have only one y value. You can think of the function as a machine, like we said earlier. And then, so this is repeated. Anytime I repeat something in my course, it's because they repeat it in the manual, but we just did it, so I'm going to skip that. Understand problem-solving situations and know how to translate them into expressions and equations. There are many different types of problem-solving situations students can evaluate and use equations and expressions with variables to solve. For example, a sixth grader wants to go on a field trip and needs to save $100. He mows lawns to earn money. He charges $20 to mow, and each time he mows, he spends $2 in gas. How many yards does he have to mow in order to have enough money to go on the field trip? They do ask questions like this on the test. So in this case, the student can make an equation or they can guess and check. First, we'll show an equation. So we know he needs $100 and he earns $20 each time he mows, but he spends $2 in gas. So his profit is $18, right? 18 times something equals 100. 18x equals 100. Now we can solve for x by dividing by 18 on each side, and we get 5.555. Well, you can't mow 5.555 lawns, right? So we know we need to round up. He needs to mow 6 lawns in order to have enough money. Let's say you're not really good at making equations and that doesn't make sense to you. You could guess and check. So we could pick 3. We know he made $18 times 3. That's not enough money. That's $54, right? Continue plugging in the numbers until you get a number that's more than 100. And when they get to 6, then they'll know, right? So you would do 18 times 4, 18 times 5. So see how this actually takes longer, the guess and check. Takes longer than making an equation. Proportional reasoning. So a lot of people struggle with proportions, ratios, and percentages. These are skills taught in 6th grade, but the skills that build up on that are taught before, like fractions and decimals. Teachers can explain proportions in real-world terms to help students understand. A 6th grade class is reading a novel for English language arts that is 200 pages long. The students have been complaining about how long it is taking them to read the assigned chapters. The math teacher tells each student to time how long it takes him or her to read 10 pages. Each student must use proportions to figure out how long it will take him or her to read the entire book based on the data he or she collected. Tim reads 10 pages in 20 minutes. How long will it take Tim to read the entire 200-page book? So 10 pages, we're going to put that over 20 minutes. We know that. He timed it, right? So pages over minutes. The book has 200 pages. We're going to put pages on top to match this, but we don't know how many minutes it's going to take for that, right? So here we can cross multiply 20 times 200 and 10 times x, right? So 10x equals 20 times 200. Then we have 10x equals 4,000. We divide each side by 10, cross out each zero, and x equals 400. It will take him 400 minutes to read the entire novel. So see, that's a real-world application, something that's relevant to them. They can budget out their time and see how long they need to read a book. To determine which linear function best represents a set of data, you need to use the data and check it against those functions. For example, if this is your data set, here are 4 functions given. You must determine which function represents the set of data above. So let's fill in the data for function 1, y equals 2x. Y equals 2x, so 1 equals 2 times 0. We can already see that's not true, right? 1 equals 2 times 0. So we know 1 is wrong. 2, y equals x minus 1. Y equals x minus 1. 2 equals 1 minus 1. That's also false. Now y equals x squared. 1 equals 0 squared. That's also false. So we already know that this one is right, but let's look at it and make sure. Y equals x plus 1. 1 equals 0 plus 1. That's right. And then you would keep going and plugging in the other values to make sure it's right. And it is. So see how the algebra we're doing here, it's not super complicated. Now we have inequalities. This is when we have greater than and less than. So y is greater than 3x plus 2 and y is less than x squared. The students start doing equations with inequalities in, not equations, but inequalities in 6th grade. Teachers can give students real-world scenarios to make inequalities more relevant and interesting. Bob is a 6th grade student that is technologically savvy. His neighbors hire him to fix their computer and pay him $8 per hour. He is saving for the latest PlayStation and needs to earn at least $400 to buy the gaming system and equipment he wants. How can an inequality show him how many hours he needs to work to earn at least $400? First, go over the information we know. He needs to earn at least $400 to buy what he wants. He makes $8 per hour. How many hours does he need to work to make at least 400? So we want the number of hours he works times 8 to be greater than or equal to 400 because he needs 400 or more dollars, right? And $8 is the dollar per hour he makes. X is the number of hours he's going to work, but we don't know how many hours that is, right? Now we're going to divide each side by 8, and we're left with 50. So he has to work 50 or more hours to earn $400, right? Now we have systems of equations. When you have 2 or more equations with variables, you can solve for variables. For example, x plus 2y equals -8, negative x minus y equals 9. First, isolate one of the variables in the first equation. So here we're just going to subtract 2y from each side, and we have x equals -8 minus 2y. Next, plug that x equation into the second equation, right? So here we have -8 minus 2y. We're going to plug that into x right here. So we have -8 minus 2y minus y equals 9. These negatives carry over. That turns into a +8. That turns into a +2y minus y equals 9. We combine like terms. The 2y minus y becomes y. 8 plus y equals 9. Y equals 9 minus 8, so y equals 1. Now we're going to plug the value of y, 1, into either equation to solve for x. Negative x minus y equals 9. So we have negative x minus 1 equals 9. Negative x equals 10. We multiply each side by -1, and we're left with x equals -10. Then you just plug in your values to check your answer. We have correctly solved this system of equations, right? Just by plugging in the values. So you can always check your work. All right, so for algebraic methods, we have to use our basic operations: addition, subtraction, multiplication, division, know how to solve for variables using all operations. So 4 plus x equals 6. X equals 4 minus 6 minus 4. We subtract 4 from each side, right? X equals 2. For multiplication and division, 4x times x squared equals 32. Multiply x and x squared, that's x cubed. We keep our 4. 4x cubed equals 32. Divide each side by 4. X cubed equals 8. Remember, x cubed means x times x times x. So what times what times what equals 8? Well, we know it's 2 times 2 times 2. If we didn't know, we could keep guessing and checking until we figure it out, right? When we have polynomials, we have to combine like terms. So 2x plus 5x plus 7 is 7x plus 7. Or whenever we're multiplying exponents, we multiply across here. So 10x times 5x becomes 50x squared, and the y cubed stays the same. Factoring polynomials, honestly, this gets really complicated, and it takes a while to learn. So I think you'll see maybe one question on factoring polynomials, if even. So I don't spend a lot of time teaching that. I go over it very briefly, and then I encourage you to watch some videos on Khan Academy. But if it's really hard for you, you're better off getting good at other things where you're going to get more return on your investment, right? So I'm going to skip over that because that takes a really long time to go over factoring polynomials. But Khan Academy, that guy explains it really well. And then we need to do PEMDAS, or please excuse my dear Aunt Sally, where we go over the order of operations. So first, you do anything that's in parentheses. Then you do the exponents. Then you multiply and divide. Then you add and subtract. So let's look at this. 5 minus 2 cubed minus 6 divided by 2. First, we're going to do what's in parentheses. So 5 minus 2 is 3. We have 3 cubed minus 6 divided by 2 in parentheses is 3. Next, do the exponents. 3 cubed is 3 times 3 times 3, which is 27. And then we have to subtract the 3, which we have 24. All right, which of the following equations is represented by this graph? So we want to look where it crosses the x-axis. This axis right here is 0. So the y-intercept is 0. So I already know that A or B is going to be correct because A and B have a y-intercept of 0. The equation for a line is y equals mx plus b, where m is the slope and b is the y-intercept. So the y-intercept we already know is 0, where it crosses the x-axis. So it has to be A or B. Now let's do the slope. Slope is rise over run. So here I go over up 3, rise over run, up 3 over 1. Right? So up 3 over 1. And then to get from 1 to 2, I go up 3 and over 1. So see how my slope is 3. So the correct answer is y equals 3x. Right? Another way I could do that is let me clear this out. I could graph it. I could write out the coordinates, right? And then look for a pattern and see what the slope is. Right? So I could do it that way too. I always show you multiple ways to do things. And then you can guess and check it. Right? So that's how you do that. Let's look at some sample questions and then we'll be done. So I'll let you guys answer this in the chat box. I don't see any answers yet. I'll give you one more minute. Oh, okay, good. We've got an answer. D. Let's see. Good. D is the correct answer because it is the most learner-centered way for students to use algebraic reasoning. They are participating in a hands-on activity and must figure out what comes next in a pattern. A is incorrect because it is not the most learner-centered option. B is incorrect because kindergarten students will not be likely to be able to count by 20s by 100. So, and it's not learner-centered. C is not learner-centered. I also want to show you something that this is, I don't know of anybody else that has this. So I have courses for EC through 6 if you don't have a course that you like yet, right? The course that I was showing you for math, but I also have them for everything else. So I'll put this in the chat box in case you want to enroll in my core subjects courses. And if you only need one subject, you can just enroll in the subject you need. But I also want to show you that I have, you've probably noticed that about 20 to 25% of the questions are situational, where they say, what's the best way to teach something? And I made a course to teach you just how to answer that. So let's say you already have a good program that you're studying and you like it, then maybe you don't want my courses, right? But you might want my situational questions course that teaches you just how to answer the scenario-based questions, because those come up on every subject of the test. So that concludes tutoring. I have to get ready for my next tutoring. I have group tutoring for a different test coming up pretty soon. Do you guys have any questions or comments? So you can enroll in my courses if you found this helpful. And then I try to do this about once a week, so you can check back for Facebook or for emails for the next session. But thank you guys so much. I hope you'll have a great night. Oh, so to go to my courses, just go to that website that I put in the chat box. I'll put it again. Click on that link. And then if you need all subjects, click on course subjects, all subject courses and tests. And then just choose if you want to pay by the month, a subscription, or if you want to pay one time and get it for 3 months. So it's a little bit cheaper if you pay one time and you get it for 3 months. So however you want to do it. All right. Well, thanks so much, guys. Have a great night.